Good morning to one and all. So today let us solve a problem on a three-hinged parabolic arch with supports at different levels. So let us begin. Now how it is different? You can see here how this three-hinged parabolic arch with supports at different level, how it is different. You can see here, this is the support A here and this is the support B. Now these two are not at the same horizontal line. Along the same horizontal line, these two are not there. Now because of this, you can see here. Here you can see this is the center, that is crown, that is hinge is here at point C. Now the distance between A and this crown, vertical distance is h1 here, whereas the same thing, that is from B crown, the vertical distance is h2. Rest all is same here, rest all is same. Total span between A and B, the horizontal distance between A and B is L. So we need to remember two more expressions here. You can see two more formula you have to remember in order to solve this problem. One is, you can see, L1 plus L2 is equal to L. You can see the diagram here. L1 and L2 must be equal to L. So this is one formula that you have to remember. Second one is this one, that is L1 by L2 is equal to square root of H1 by H2. Now after this one more small this one point is to be noted here. Now you look at this curve and compare this one with this. Here you can see A and B dash are at the same levels. You will be wondering, what is this? What is this one? So what I have done here is, I have taken this A and C and I have extended it like this. Extended. This curve is extended like this. So this curve is extended like this. So since this one is L1, another L1 you should take here. See this. Another L1 you should take and complete this curve. So whenever you want to calculate vertical ordinate at any point within AC, that is vertical ordinate within AC, this curve has to be used. So for example, Y1, I want to calculate Y1 for the point D, which is in between A and C. Which is in between A and C. I have to draw this curve first, so that this is L1, this is also L1, this is H1. See this one, this is H1. Now I am in a position to apply the usual formula, whatever we have used in case of parabolic arches, to find the ordinate that can be used here. Similar situation will be there if you want this side. You have to extend this curve this side, which will be L2 and L2. You can see here. So this is L2 and this is L2. Similarly, you can extend this curve if you want to calculate Y ordinate when the point D is in between C and B. So this will be more clear when we start solving the actual problem. So let us take one simple example here. You can see this is a problem of a parabolic arch wherein supports are at different levels. And the usual load is, that is, you can see the left half is loaded with 30 kN per meter. And now let us find out this bending moment N and Q values at 15 meter from the left support. From left support, you have to find these values at a distance of 15 meter. So I have used this formula here, as I told you in the beginning. The formula to be used here is L1 by L2 is equal to square root of H1 by H2. So use this one and find out L1 and L2 values. Now you can see here L1 by L2 is equal to square root of 5 by 3. So this L1 is in terms of L2 now, which is 1.3 L2. Now we use L is equal to L1 plus L2. You can see here. So now you can see the span is 40 meter. So 40 is equal to L1 plus L2. Here 1.3 L2 you have to substitute in place of L1. So you end up with 17.4 nearly L2. Then L1 is 22.6. So total is 40 meter. So let us move on to the next calculation. So determine the reaction components here. See, one difference here is you have to start with MC first, sigma MC. So this is one change here. You cannot use sigma MA or MB in the beginning. Use this formula first. You will have some equation here. So sigma MC equal to 0. Consider the right of C. Consider the right of C. Right part of C is this one. This is right part of C. Now we can see, I'll show you here. VB, see the VB into this distance is 17.4. So this is anti-clockwise. So minus VB into 17.4 plus HB into 3. See this HB into H2 is 3 equal to 0 because only two forces are there on the right side. Only these two forces are there on the right side of C. So this will give you an equation like this, which gives HB is equal to 5.82 times VB. Let us call it as equation 1. After using this one, after getting this one, now use sigma MA equal to 0. So sigma MA is equal to 0. You can see the entire this one minus VB into 40. That's about this point. Minus VB into entire span, force into perpendicular distance is 40, minus 5.82 VB into 2. Now what is this? This is nothing but HB, carefully observe this one, HB into perpendicular distance. So what is the perpendicular distance between HB and the point A? That is vertical distance. So vertically they are separated. Vertical separation between A and B is 5 minus 3. That is written here. So you be careful about this HB here. Once again you observe here. HB, this is the horizontal force, and the distance between the horizontal force and the point A, which is vertical distance, which is nothing but H2 minus H1, so which is 2 meter. So this is important here, plus point load related moment. This is a UDL related moment. It is 30 into 22.6. So this is 22.6 now. L1 is 22.6 into 22.6 by 2. This is the moment produced by UDL about the point A. So let us move on to the next calculation. So this will be, see this equation is will yield VB is equal to 148.4. Therefore VA, so total upward and downward forces must balance. On that, VA is equal to 529.6. Now you substitute this one in equation 1, which is here. We can see this. Substitute this one in equation 1, which is here. You will get here HB equal to 5.82 into 148.4, which is VB value. You can see it is here. It is substituted here. Now I am getting HB as 863.7. The horizontal forces must balance each other here. Sorry, that is, this HA must be equal to HB. Let us call it as capital H. So this is 863.7. Let us move on to the next calculation. Now let us calculate the bending moment N and Q values at 15 meter from the left support. Now you can see here. Let us see this distance here. You can see here. So this one is to calculate this y1 value. So this is an important calculation. Carefully observe here. So what I will be doing is, in order to find y1, I should complete this part of the parabolic curve like this. So what I have done is, you can see this AC, which is 22.6. This is L1. I'll extend this curve till this point, so that this is also L1 and this is also L1 only, which is 22.6. It means AB1 is 22.6 plus 22.6 it is. In this way the curve is formed, this parabolic curve is formed, so that I can use this formula y1 is equal to 4h1x by L dash square. So what is L dash here? L dash is nothing but distance between A and B1. This is L dash, you can see this, which is nothing but 2 times L1. So that is taken. Now see, for this curve which is ACB1, I can use the usual formula, which is y1 is equal to 4h1x by L dash square into bracket L minus x. You can see this formula has been regularly used for the full parabolic curve. Now we substitute all the values here. X is horizontal distance is 15 meter. The horizontal distance between A and the point D is 15 meter, that is x. L dash is the total, that is L1 plus L1 it is. So 45.2 H1. See, for this entire parabolic curve ACB1, H1 is total, this one, which is 5 meter. Now you substitute all this, you will end up with 4.43 meter. Now see, you want to calculate the theta value also. For that one you have to differentiate this one. Dy by dx is equal to tan theta. Now I have differentiated. This is as usual it is. We are just differentiating. Already we have solved problems on parabolic curves. Same formula is there. So 4h1 by L dash square into bracket L dash minus 2x. Same formula is there in the previously solved parabolic arch problems. Now if you substitute all these values carefully, equal to, you will get 0.15. Tan theta is 0.15, theta is 8.5 degrees. So moment at D, in order to find moment at D, draw the line, draw this free body diagram AD separately like this. AD separately should be drawn. Now the free body diagram is in equilibrium because see, there are forces here H and VA. I have not shown it, but VA and H are the two forces, plus up to D UDL is acting here. So here up to D some UDL is acting here. Some UDL means 15 meter it is. This is 15 meter. So 15 meter UDL is also acting on this one. So this UDL V, which is introduced for maintaining this equilibrium of free body diagram, this V and H are introduced to keep the system, this part of the body in equilibrium. V and H are introduced. So H and H has to be same. Sigma H is equal to 0 means this value will be same. So there is no problem in calculating H value. How do you find V? So total downward force must be equal to total upward force. Carefully observe here. Total downward force is V plus UDL must be equal to VA. That is why V is equal to VA minus UDL. So it is 79.6. So now you know how to find the value of V. This V calculation is very important. Carefully understand this one. Now once you calculate V, once you calculate H, this H is already calculated. Whatever H is introduced to keep this free body diagram in equilibrium. Try to understand from your first year mechanics. This free body diagram is in equilibrium means there has to be one force vertical which is counterbalancing the forces of UDL as well as this one. One more force is H, which is introduced to counterbalance this one. These two are equal. So in this way finally you should calculate correct value of V here. Rest all is same now. Substitute all these values of V and H. One is 866, one more is minus. This will be minus 48.9 kilonewtons. In this way the entire problem is solved. Thank you.